today. I've been given a very noble job of standing between your lunch and the speaker, so I'll try to remind you of the time. The first talk is by Professor Anuradha Misra, so I'll remind you when it's 15 minutes.
Okay, first of all, thank you very much for this opportunity to talk about Rohini. The title of the talk is Investigating Transverse Single Spin Symmetries to Probe Gluon Sivers Function. I have added with Rohini Godbole because there is another talk by Abhiram Kaushik tomorrow and you will hear more of single spin asymmetries there. And as you can see from the ratio of the letters, I may end up talking more about Rohini than about the subject. So my association with Rohini goes back to about 40 years or so. So this is the first SERC school. I want to correct Sudhir, this is the first school which was in 1985 and I was a participant there, and you can see Rohini sitting over here. You can see many others also. Professor Mukunda is there. There is Anant Narayan in the corner, in this was the very first school, and we had 2 weeks of very rigorous lectures by legendary teachers like Mukunda and Tulsidas, K.L. Sharma, and then at the end of 2 weeks we heard that there is a very young lady coming to give some lectures on W and Z physics, and you can see the ratio of women at that time. We were just 6 of us, the girls, and we were super excited to see who is this young lady. And Rohini came. This was in old building, and there was a large room with a very high table where everybody was giving lectures, and Rohini could hardly be seen behind the table, and we saw her and we were really shocked to see the size of the speaker. But then she started talking, and she was a giant among all the giants they were present there. So that was my first introduction to Rohini, and this is my last meeting with Rohini. This is 2024 February when she had come to IIT Bombay for some review or something. So I am going to talk about many qualities of Rohini, and one of them you can see in this picture. She is wearing the same sari that she was wearing for the Padma Shri and again for meeting the Prime Minister Modi. So she was she didn't care about all these small things. In between this long span, there are people who know her for longer actually, but I had interactions with her of many kinds, and that is why my research with her is only a small part of my journey with her. So she had many hats to her for different people, and for different people in the audience also. She was a teacher for some, she was a mentor for others, she was a colleague for many of you here, and she was a collaborator for almost all of us here. And for me, she was all of these. So she taught me in 1984 SERC school, as I told you, and then there was a gap of 10 years. So I completed my PhD, and Rohini was working in Bombay University. And in 1994, this was the time when Rohini was looking for a change, for shifting to Bangalore. And I was trying to find a job in Bombay because my husband had a job in IIT Bombay. And I was told that there is a research associate position with Rohini Godbole. And Professor Mani, he was the director of HRI at that time. I was there for a short visit. He told me, just go and meet Rohini Godbole. I have put in a word. I meet Rohini with a 4-5 year gap, in which I had nothing officially except for 2 semesters of teaching at Stony Brook, 1 paper which had Stony Brook affiliation, but just because I was a guest lecturer there, and that's it. And no experience in phenomenology, which was the project was about. But Rohini met me, and she was very keen that I work with her. I was also going to expect my second child next month, so it was clear that in the next 6 months or so I'm not going to do anything. But Rohini knew that, and she actually understood it. And I joined as a research associate with her. The reason she wanted me there was because she was very, very worried about what will happen to the teaching of particle physics in Bombay University after she leaves. So she wanted somebody who can, in the next round of recruitments, she wanted a particle physicist to be there. And if you are in the system, then your chances get better. That's what she told me. So within 6 months, I became a lecturer there. And so my period as a colleague with her is just 6 months. That is, so there was one semester in which both of us were faculty members at University of Mumbai. She was so concerned about the teaching at University of Mumbai. She told me that why don't you sit in my class and try to get a feeling of what the students here are like. And I was not very comfortable with that, but I still agreed to do it. And I did learn a lot. First thing was that for Rohini, teaching was as important as research. She considered it like a puja, like a worship. So in the first class, she comes with a white sari like Saraswati and with flowers in her hair, which she never did normally. And she was very compassionate with the students. So after that, after 6 months, she left. And as things are, in the last 30 years, I have been the only person teaching high energy physics in Bombay University. So that decision for her to take me as an RA was very far-sighted. And then I actually started collaborating with her in 2009. So she, which I'll talk about. But apart from all these things, she had a much bigger hat for me and for many of the girls here, which was she was a friend, philosopher, and guide, and a role model, which she has been for me from 1994 till now. So I would like to also talk about her stay at University of Mumbai, which I think many of the people may not be aware of. She was a teacher par excellence. The people who were taught by her, many of them are now college principals or teachers in Mumbai University, and they all speak very highly of her. She used to take her, she was, in this period, she was also doing research with TIFR. So she used to spend a lot of time in TIFR. Other teachers in university used to object to that, but you will listen about it from her own mouth in a couple of minutes. So she used to request that her class be scheduled at 9 o'clock. 9 to 11 she would take the class, and 11 o'clock she would take a local train and go to TIFR, work whole day, come back in the night, and next morning again, these 2 hours. So, but she was very serious about her teaching. She never neglected her teaching duties for the sake of research. She was involved in the growth of the department by framing the particle physics syllabus even after and refining it even after she left university. She always, even after joining ISC, she always came to Bombay University to science communication, public lectures like this, and so on. And then she started research with me and my students. And she was also the chairperson of the board of management when our department became autonomous department. So I have this small reel. I'll tell more about from where I got it later, in which she talks about her time at University of Mumbai. So,
25 years since I left, and maybe other 14 years we have spent here. So, it's a story 35, 40 years. And many things come to mind. I came here as an inexperienced person who had much experience beyond research in science, and so therefore coming here, understanding how to teach, how to deal with the university atmosphere, and how to best make yourself useful to the student community, as well as continue with your personal research. I think this was the challenge. And the challenge was like this, I'm specifying it, because compared to the rest of the world, they are teaching and research at two sides of the same coin. In India, somehow, historically, research institutions and teaching institutions got bifurcated a long, long time. As a result of this, research was not part of the university atmosphere as it was. You see, also I would say, because of the same similar things and historical accidents, the funding level was also very different to universities and the autonomous research and educational institutes like the IIT, like the Tata Institute of Fundamental Research. So I came here from a research atmosphere, a young person, and coming here was actually a new experience, a new set of challenges. And as a matter of fact, I can tell you that some of my senior colleagues in the Tata Institute have told me, really not just forget about it. It's not possible to continue doing quality research when you are in university. But as it happens, now clearly today where I am sitting, that fear is not motivated. It's something else. Of course, it must be because I really wanted to do it, it was a passion, and I worked. But I think it would not have happened in the, unless there were a few people here, and I can even mention a name or two. Professor Abbas Mangala, and I went to his office and he said, welcome, welcome, we would love to have you here. And that welcome, right? Point is that he was actually from Tata Institute research, so he and theoretical physicists. So he knew what my passion was, he appreciated it. Also, luckily, I was theoretical. So I didn't need big labs, big investment to set up a lab, to run a lab. That was easy. And last there was this support from this end, and of course they were welcoming people in the Tata Institute of Fundamental Research, my ex-colleagues, students, postdocs, who again appreciated the fire that was burning. So all this actually joined together. Luckily for me, I was invited to the University of Mumbai to give a leave of absence, unpaid, for 2 years, or sabbatical, kind of sabbatical for a person who had just joined and not even a year old in the university. Because it was a period in Dortmund that really helped me blossom as I entered.
So, as we know, she came into as an independent researcher during this period, and she did very important work during this period. And she continued to come after that also. This is a picture when she came to conduct a teaching learning workshop when Professor Rangwala, about whom she was talking, was awarded the INSA Teacher Award. Then there were popular talks, there were women in science talks. She came for international conferences, both online and offline. And this picture is a picture of an online meeting which we had on the last day of my retirement when she was the chairperson of the board of management. She insisted that it was a Sunday, and she insisted that we should have a meeting. So, and last but not least, she remained connected as a research collaborator with me, and she was an inspiration to my PhD scholars, who, mind you, were working with a one-person HEP group at Mumbai University. So these are some papers which we wrote together, along with my students, 3 of them, and Abhinam Kaushik, her student, who will be giving a talk tomorrow, and in the beginning with Asmita Mukherjee. And Rohini's contribution in this was, substantial. First of all, she had the insight. This was a problem which was new to all of us, including the student. And Rohini had deep insight into the subject, and she actually, the student was a new student, just a fresh MSc, and she actually sat with him in one of the labs at IIT Bombay, I remember, and she taught him how to write a program in Fortran. So he was really engaged with the students. And so let me coming now to the subject. We worked on transverse single spin asymmetries in certain processes. So let me start with a very quick introduction to transverse single spin asymmetries. These asymmetries arise when you have a collision of a unpolarized target with a polarized beam of protons, and these are expected to give information about the spin structure of the proton. So asymmetry, as it is defined, is the difference of cross sections when the incoming beam is polarized in a direction upward as compared to the direction of plane of production, and the cross section when it is in the downward direction. As a result of this symmetry in the distribution inside the parton, there is a asymmetric distribution of the scattered particles, which is called transverse single spin asymmetries. These symmetries have been observed for about 35 years now, and even at higher energies. So how do we explain these symmetries? These asymmetries arise because of the orbital motion of quarks and gluons, or due to recoil of gluons radiated from the active quarks. So in a parton model picture, where you take the parton distribution functions to be depending only on the x variable, these asymmetries cannot be explained. You have to take into account the transverse momentum dependence of the parton distribution functions. So there are two major approaches in the field which are used to explain these asymmetries. One is a higher twist approach, and the other is a TMD approach, which is what we decided to use. So what you do in this approach is that you modify the factorization theorem by including the transverse momentum dependence of the parton distribution functions and the fragmentation functions. This can be done for unpolarized scattering cross sections also. Now this TMD factorization is a very rich field, and it includes the spin and intrinsic transverse momentum effects in the PDFs and fragmentation functions. The way it is done is by introducing a term of this form, which defines a spin orbit coupling kind of thing, and depending on what is S in your particular experiment, or what are P1 and P2, there are different kind of transverse momentum dependent PDFs which can be defined. So this factorization has not been proved for all the processes. So some of the processes for which it has been proved are SIDIS, Brilliant, E plus E minus annihilation, and so on. And in many other phenomenological studies of transverse single spin asymmetries, people use it without the proof, and it is called the generalized parton model approach. So you assume TMD factorization and you calculate things. So this is what is we decided to do with one of the TMDs, which that is a Gluon Sivers function. So okay. These are different TMDs which have been which can be used for defining various processes, and the one we decided to work on is Gluon Sivers function, which defines the correlation between nucleon transverse spin and the parton transverse momentum in the polarized nucleon. So Sivers effect is the asymmetry that appears in the scattering cross section because of the asymmetry in the distribution of partons inside the proton. So this anisotropy at the partonic level shows up at asymmetry in the final state distribution. And to get the information about a particular TMD, you have to find an appropriate process and an appropriate kinematic region in which you should look for asymmetry to get the information. So the quark's Sivers function was at that time quite well known, and is well known now also. But Gluon Sivers function is something which is not really understood, and we decided to investigate that. So the question was, can we get a direct probe of Gluon Sivers function? So basically you have to look for a process in which the contribution of gluons is more. And Rohini pointed out that traditionally the final states which dominated gluon determination consisted of heavy quarks. So probably you should, and with all her experience with heavy quarkonium, we decided to work with heavy quarkonium. And we have done work with both open and closed charm production. And de-meson production was already discussed. But Rohini said that let us look at electroproduction of GEPSI because it becomes a very clean probe. So there is just one partonic process. So this is her statement. So I was worried about the TMD factorization not being proved for this process. And then she said that in fact the road from Parton model to QCD improved Parton model also went through such approaches, that you take a phenomenological approach, assume factorization, do things, and then try to get information about the details. So this is next from her talk in Light Cone Conference in 2017. We started with low virtuality leptoproduction of GFPSI, and so this was work done with me and my student at that time. And later on we did some more work on beam production and also on direct photon production in EP collision and both PP collision. So I will very quickly give the example of the first process that we studied. And so you define the asymmetry as n upon d, where n contains the Gluon Sivers function and d is the total cross section. And we used the William-Weizsäcker function to represent the probability of having this photon with a certain momentum fraction of the electron. And we also assumed certain, so we started with a very simple model, and then we started improving by bringing in the evolution effects and so on. So what some of the results that we found were that the asymmetries were substantial, and when we this is not TMD effect, this is TMD evolution effects. So this and the lower graphs are the plots when you take into account the TMD evolution. I missed the word evolution. When the TMD evolution effects are taken into account, then you find that the asymmetry reduce. So this is the work, these are the processes we studied, and we'll hear more about it in Abraham Kaushik's talk tomorrow. We also did some work in direct photon production, which also I'll skip because I want to show something more. Basically, the result for this direct photon process was that it requires two kinds of Gluon-Sivers function, and prompt photon production can be used to distinguish between the two kinds of Gluon-Sivers function. That this was a very good result that we got. So continuing Rohini's legacy, we are now currently working with some master's students and my former students. I am retired, so I cannot take any PhD students officially. So they are working on a new improved color evaporation model that has recently been introduced, and it is found to have good agreement with data for charmonium production. So we are using that, and this and then we are also looking at photon plus jet production with again my ex-student and a student from NICER, Bhubaneswar, who is mentee under NIUS program of HBCSC. Another legacy is that particle physics continues to be one of the most popular electives at University of Mumbai. Number of students are going on for research in high energy physics at various institutions. In fact, many of the PhD students at IIT Bombay have done their masters from us, who are working in the spin physics only. Leelavati's daughters continues to inspire the next generation. I was one of the lucky authors in the book, and I keep on getting emails from young girls saying that because of I read your article and I decided to come back after reading it. So it's very fulfilling for me, but I think it's somebody relates to some story or the other, and Rohini's original vision to work for women who have a break and who come back after a break should be given a chance is being really served by this. So but I think Rohini's legacy is much more beyond her physics contribution and the Women in Science initiative. There's a movie which is being made about her documentary, and many of you have been interviewed for that documentary. I managed to get a clip from there where she talks about what she thinks should be her legacy, and I completely agree with her.
I think in my life, my science also started accidentally. My women in science activity also started accidentally. But I believe that is one area where I have also been able to leave some specific impact behind. And in the case of science, it's sort of, as I said, it's a small problem. In the case of women in science, I think I've been able to even in practice with the doctors who do not didn't exist almost. Nothing much existed in science. What makes me happy is that at the end of the day, I can look back and say that there are few small things which I did, which were not known to people before I discovered. They're small, but this is like, the proverbial squirrel putting a few grains of sand in the Ramasetu. The legacy that kind of, that I would like sort of people to remember you is that if you sincerely make your life, if you keep on walking underground, if you keep on sifting the sand, sometime, somewhere, you will do that.
Thank you. And I thought a conference will not be complete without something hearing from Rohini. And I completely agree with her about her legacy. She was a brilliant physicist, no doubt, but there are many other brilliant physicists also. But her qualities of this perseverance, determination, hard work, these are the things that make her Rohini Godbole. Thank you.